Share. I always miss on this one. All right. So we do have, did I not press? Okay. So we have our, we're going to talk a little bit about the paper. What does that mean? How do we read? What is all this grid? So when we look at the grid of the EKG paper, we have two references. We have the time and then we have the voltage. The time is going to go horizontally on an x-axis, and then the voltage is going to go on the y-axis. A couple of points here is when we look at the EKG paper, it's going to look like a grid, and it's going to be small squares inside of a large square. We're going to call a large square this, and then the little tiny squares. So we're going to pull one of the large squares and pull it out, and this is what's going to, a small square or a large square is going to look into a large square. So let's just keep in mind this going across this, that's a large square. Anyone you pick around that, we're going to call that large square. Now, in a large square, we have 5 small squares horizontally, and we have 5 squares vertically. When we're talking about time, one little square is going to be 0.04 seconds. Therefore, if we multiply that by 5, because each large square has 5 small squares, is going to give us 0.2 seconds. So every large square is going to be 0.2 seconds. So when we add 0.0.0.2, 5 large boxes is going to give us 1.0 seconds. Okay, and then we have the 10 millimeters. So let me explain that on the next two slides. But for now, let's talk about time. One small box, as we said, is 0.04 seconds. 5 small boxes is 0.2 seconds, or one large box is also 0.2 seconds. So are we speaking small boxes or large boxes? They're both 0.2 seconds. Now, 5 large boxes are 1 second. So we're talking about not the little boxes within a box, but the 5 large boxes. 15 large boxes is going to be 3 seconds. 30 large boxes, therefore 6 seconds, and 300 large boxes is going to be 1 minute, because our unit for heart rate is beats per minute. So we want to know how many times the heart beats in a minute. And we have the normal speed of your EKG has to be 25 millimeters per second. That's super important, because otherwise the image is going to be distorted a little bit. Now let's take a look at voltage. When we look at an EKG, we have to have a mark in either one of the ends, right or left end, that is going to indicate the voltage of the image. For a proper voltage, we're going to have 2 large squares, which are going to represent 1 millivolt. Now, one small square, when we look at these large squares, one little tiny square within a large square is going to be 0.01 millivolt. 5 small squares is going to be 0.5 millivolts, or one large square is going to be 0.5. So 5 small or 1 large are both going to be 0.5 millivolts. And 2 large squares, which is what we need to see, is going to be 1 millivolt. When we put it together on an EKG, we brought now the EKG that we have seen before in the class before. We're going to see here, we're going to have to check the speed is 25 millimeters per second, and the amplitude or the voltage is 1 millivolt, or 2 large squares. Okay, and then we can see here, our EKG that we already talked about, the P wave QRS, and the T wave, that's 1 beat, and then it continues to the next beat. It's going to start making sense, but make sure the calibration is done right. What is the calibration? 25 millimeters per second horizontally on time, and then vertically on the voltage, it has to be 1 millivolt or 2 large squares. Okay, so here are some of the important measurements. We already talked about that in the previous class, but let's go ahead and do it again. The most important measurements on everything is important, but for us to diagnose or to interpret a EKG strip, we have to take a look at two very important numbers. The PR interval, which has to be between 0.12 and 0.2 seconds. And if we remember 0.2 seconds, it's equal to 1 large square. That's going to be super important to be fast when we're diagnosing. And then QRS complex has to be less than 0.12 seconds or 3 small squares. So not even 1 large square, 3 small squares. That's super important. And then we did talk about the PR interval, the PR segment, the ST segment also to identify STEMIs because it's ST elevation, myocardial infarction. And then also we did talk about in the previous class when we are trying to measure a heart rate or blocks or anything else, we're going to go ahead and measure our interval. So we're going to find the R wave in the QRS complex and measure it to the next one like we did in the case before. Therefore, we have a couple of questions here. If one small square, because we did talk about this little tiny square, this is a large square, and within this is a large square, and within the large square, oh wait a minute, this is not a small square. One tiny square is going to be 0.04 seconds. Therefore, how many squares is 0.2 seconds? I'm going to give you like the Wheel of Fortune time. Okay, the answer is going to be 5. This is going to be a Q number when we're looking at the PR interval. Our PR interval cannot be in a normal conduction. It cannot be longer than 0.2 seconds. Therefore, it cannot be longer than 5 small squares or 1 large square. Second question, how many squares is 0.12 if 1 small square is 0.04 seconds? I'm going to give you the Wheel of Fortune music again. So your answer is going to be 3. And that is because the QRS should not be longer than 0.12 seconds. That will talk about ventricles that are not doing their job. So it has to be between 0.08 and 0.12. That will be a good measurement for our QRS. That's super, super important. Okay, so we have seen this before. This is the EKG that we saw in the past, because we're going to start talking about reading how to estimate the heart rate. Speaking a little bit about identifying the lead that is going to give us a best view when we're interpreting, but in this case, we are going to take a 12 lead EKG 6-second strip to determine the heart rate. And let me see. On this 12 EKG example, the first way to identify our EKG, the heart rate in an EKG, is going to be the 6-second rule. For a 6-second rule, we have to have a 6-second strip. And like we said before, this, if we only take like lead 1, is not 6 seconds or any of them. The only one that we have 6 seconds of information will be the bottom lead, which is lead 2. So the rule says on a 6-second lead, we are going to find how many QRSs are there in a 6-second. So if we count here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 QRSs in a 6-second. So for 6 seconds to be 60, which is a minute, we have to multiply by 10. So if we have 12 QRSs, we're going to have to multiply by 10 as well. So 12 times 10 is going to be 120, which is 120 beats per minute in this case. And it's rough. This way to count the heart rate it's like a walk by. It's a very fast. It's not very accurate, but it's going to give us some information. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 multiplied by 10. It's 120. This might be a little bit more though. Okay. Then the other two ways to estimate the heart rate are going to be the large square method and, oh, I put both large and the small square method. So let's go ahead and let me see if I can kind of make an annotation here so we can, so we're not that confused. Okay, let me see. I'm going to use, we're going to cross large. We are going to do small. Yeah. Okay. For these two ways to estimate the heart rate are for regular rhythms only, while the 6-second rule is, oh, I think I have it on the next slide, so I'm gonna leave it at this. The large square method, we're going to, remember we talk about large square and small squares. Okay, so for the large square, we are going to find the two consecutive R waves, remember QRS, so we're going to find the peaks or the higher deflections on the QRS and count the numbers of large squares and divide into 300. So in this particular case, I have, I'm going to pick, typically what I like to do is I'm going to start on an R that ends on a line or starts in a line. So it gives me a baseline so I can start counting the squares. So in this case, I have picked, it's the same EKG that we saw before. I just took a snap of it. So we're going to count the large squares between two consecutive R's. So it's going to be 1, 2, 3, 4.5 approximately. So I'm going to have 4.5 large squares, and we're going to divide 300 by 4.5, and my heart rate is going to be 67 beats per minute. This method is more accurate than the 6-second, but if we want to have a better number or more specific number, we're going to go to the small square method. We're going to do the same thing. We're going to use, if it's it has to be a regular rhythm to find this, to use this method. We're going to find two consecutive R's, and this time we're going to count the number of small squares that are between two R's. So I'm going to pick the same spot that I picked before. I'm going to start in a large square here. And I know that for every large square, there's 5. So I'm going to go by 5s instead of 1 by 1. So I'm going to go 5, 10, 15, 20, and approximately 22 squares, small squares. So I'm going to use the number 1500 because there's 1500 numbers in a minute, in a strip of a minute. So I'm going to do 1500 divided by 22, and my heart rate is going to be 68 beats per minute. So this is more accurate. This method is more accurate than any of the two. But remember, we can only use it in regular rhythms. And then I guess my slide on the large or the 6 rule, which is less accurate, came onto the last slide. So I guess I reposition it differently. We're going to count how many QRS complexes are there in a 6-second strip and multiply by 10. Why? Because 6 by 10 is going to give us 60. So 6 seconds I have, and then I'm going to count the number of QRSs that I have in this particular strip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Multiplied by 10, it's 120, which doesn't even make a lot of sense, right? We have one other way to multiply or to find out about the heart rate. And this is a little bit easier to count, but you kind of need to know the result as you go. So in this case, I'm going to start right here on a line. It has to be also regular rhythm because I'm going to use 2 R's. So I'm going to use a combination, the large square, but it's like a faster way to count, right? Instead of putting, because I don't have a calculator by me all the time. So 300 or 1500 is going to be hard to to be thinking, in my mind. So when we have an RR, we're going to find it here. So there's a chart in which 1 square away, if my QRS, my next QRS was 1 square away, my heart rate will be 300. 2 squares is 150. 3 squares is 100. 4 squares is 75. 5 squares is 60. And then I'm going to take it like that. So there is a table that is on your modules, so you can see and review. If you know this result by memory, it's going to be way easier for you to figure the number out, the heart rate. So it's going to be 300, 150, 175, and then the next one is 60. So my heart rate is going to be between 75 and 60, depending on where it is. It's leaning a little bit more between, not so much on 60, but closer to 75. So I will probably, on a walk by, I'm going to say this is a heart rate at 70, which give me 68 on the very accurate heart rate. Again, in the cath lab, this is not as important or that we need to be that specific, but it's a good rule. It's a good method to know your information. And you have your table, the large box table in your modules, because that's going to be on your RCIS. So you need to know that table by memory. Okay, and that's all I have for today.